yesterday. Some people from yesterday said they needed help. So I just wanted to review substitution and make sure y'all were okay with it. Those of you that did your work, yours looked pretty good. I started grading them this morning. So I just want to make sure we're okay with it. I know the notes videos yesterday, a lot of people said they didn't like the cartoon. So I didn't post a cartoon today. If you do like it, I can post one. The notes video for today is actually me like going over the steps, and then I do 3 examples. But here's the notes from yesterday. I'm gonna put these on Canvas also. But when we're solving systems of equations, remember a system is 2 equations that have the same variables. If you don't have a calculator, you can either graph them by hand, use substitution, or there's a third method that you can use, which you'll learn about today, called elimination. So y'all know me by now. Do you think I care which method you use?
No.
No, I don't care. Pick one of those 3 if you do not have a calculator. Now, graphing isn't always the greatest because if the numbers are really big, then it's harder to graph by hand. I like substitution and I like the one y'all are learning about today. So whichever one of those makes the most sense to you, that's the one you should use, okay? But your NC check-in, that's coming up on Monday. Tomorrow and Friday are review days. That check-in has, I think, like 6 out of the 30 questions are systems questions. So we got to make sure we're okay with systems. So to solve a system by hand without graphing, so notice how it says without graphing, you can use a method called substitution. So to use substitution, you should have learned in the videos yesterday that one of the variables has to be by itself. It can be X or it can be Y, doesn't matter, but you have to get one of them by itself. And then do you guys remember from yesterday what you would do once you have one by itself?
You put it in.
Good. You
for
put
the
it
Y or X.
Good. You put it in for whatever letter it said it equaled in the other equation, right? Then you solve that equation, and then whatever you get, you put back into the one you started with. So y'all, if you need to, take a picture of these steps. I can put this on Canvas too, though, because I know some people asked for it. So I went ahead and wrote them out. But I feel like we should just do a couple examples, make sure we're all okay, and then y'all will be free to go do your notes for today, okay? Cam, can y'all hear me? I'm wondering if they didn't take their headphones to school. All right, let's do a couple of examples if y'all are good. So I'm gonna switch to a whiteboard and y'all can do these with me. This is gonna be like our warm up for today. Make sure you are putting this in your notebook because I'm gonna be checking for these warm ups and everything too when I do your notebook check. So the first system I want us to look at today, I've got it on my phone, sorry y'all. I want us to solve this system by substitution just to make sure we're okay with it. So y'all go ahead and write this one down and then we'll get started. No, ma'am. Go over there. Go. Can y'all hear my dog crying?
Yeah.
All right, do y'all have this one down?
Mm-hmm.
Okay, so to solve by substitution, our first step, we want to get one of the variables by itself or pick one that's already by itself. So look at these 2 equations. Which one would you guys start with? The blue one or the green one?
The green one.
Okay, why'd you pick the green?
Because the first one's already in Y equals. The only thing we got to do is put that one in Y equals.
Good. Okay, so what she's saying, so what you're really saying is you want to start with the blue and put it into the green, because does everybody see how the blue one says Y equals 2x plus 1?
Mm-hmm.
So you can go put 2x plus 1 in for the Y in the green equation. So once I do that, I'm going to get 4x minus 2 And instead of a y, I'm putting in 2x plus 1. So remember from middle school and from Math 1, whenever you put something in, you need to put it in parentheses, okay? All right, so from here, what do I do?
You distribute.
Good, you would distribute the -2, right?
Mm-hmm.
Okay, so -2 times 2x, that would be -4x. -2 times 1 would be -2. And then if you bring down this, that was in front. What's going to happen right here when I have 4x minus 4x?
You're gonna combine them.
Right, so what is 4x minus 4x, y'all?
0.
Okay, so the x's go away. So I'm going to see how much y'all remember. This is a special kind of system. There's no more x's. They all went away. All I'm left with is -2 equals 6. Is that a true statement?
No.
Okay, so what do we write? What's the answer? This goes back to like the 3rd week of school when we did equations. What happens when your x's cancel? If it's not a true statement, then the answer is
0.
close. It's not true. It won't work. So is there an answer?
No solution.
There you go. So this system, the answer to this one, this is a special one. That's why I wanted y'all to get on so we could do it together. This is actually no solution. So think about it. What kind of lines give me no solution in a system? What kind of lines won't touch in a system?
Parallel.
Good. So these must have been 2 parallel lines. And if you graph them in Desmos, you'll see they're parallel. So this one's no solution. Now let's talk about this. What would happen if I ended up, I'm not saying this one ends up like that. I'm asking you what would happen if it said 6 equals 6.
It will be infinite solution.
Look at her getting all the extra credit. That would be infinite solutions. Are y'all okay with that?
Yeah.
All right, so let's do another one that actually should have just one solution. Let's do an independent one. So example 2, I got that one on my phone also. I picked some off of the check-in. So these both look similar to ones you'll see on your check-in on Monday, okay?
Mm-hmm.
And then x plus, which some of y'all did really good on that last one. We finally got the grades back. All right, for this system, huh?
Can you tell us?
Yeah, I can tell you what you got when everybody gets off. It's in PowerSchool.
Oh, yeah.
All right, so for this one, y'all, which equation would y'all start with? Would you start with the red one, if it'll let me draw, or the green? What do y'all think? I thought y'all said y'all were good with substitution. I threw you a hard one.
You can, with this one, you put 1 and y equals, and then.
Good. Look at you, girl. So neither of these say x equals or y equals. So you can't just plug one into the other like we did in the last problem. This one requires a step before you can do that. So for this one, you have to solve one of them for one of the letters. Doesn't matter which letter, doesn't matter which equation. But I see one letter that would be easiest to get by itself. So I want everybody to look at this green equation right here. Do y'all see how it's just a plain old x?
Mm-hmm.
So this would actually be the easiest one to get by itself. If you subtract the 3y over, does everybody agree this will now say x equals, and then it'll be -3y plus 5?
Mm-hmm.
Okay, so that's the easier one. So now that this says x equals, where can you, oh my God, I'm glad Brooke ain't up here to make fun of me, and Cam's not unmuting. Where can I go put that -3y plus 5 now?
You plug it in the x.
Into the other one, right?
Mm-hmm.
Good. Is everybody with me and Shania? Tiana, Denia, Jordan, y'all are good?
Yes.
Okay. Perfect. All right, so I'm going to go put negative 3y plus 5 in for this x. So this is going to be, I hate writing up here, 3 times negative 3y plus 5 plus 6y equals 16. So now we're going to do the same thing we've been doing. We're going to solve this one. So what do I got to do first to solve it?
Distribute.
Good. So this would be negative 9y. 3 times 5 is 15. Good. Plus 6y equals 16.
Yes.
All right. So what do we do from here?
Combine your like terms.
Good. So you got negative 9y and positive 6y. They're on the same side, so that's good. So what does that make?
Negative 3y.
Good. Negative 3y, and then we've got plus 15 equals 16. So now what would I do, Shania, to get y by itself? What would you move next?
15.
Subtract 15. Good job. Subtract 15 over to the other side. So this is going to be negative 3y equals, what's 16 minus 15?
1.
1. And then how do you get the y by itself?
Divide by negative 3 on both sides.
Good. So does everybody agree with me and Shania that y will be negative 1/3? I'm going to hit my dog, y'all. Y'all agree it's negative 1/3 for the y?
Yes.
Okay. Everybody else? Y'all are good?
Yes.
Okay. So now where can I go put this negative 1/3, y'all, to find the x?
You put it there for y.
Good. Put it back into the one you started with right here for the y. So x is going to be negative 3 times negative 1/3. Oh my gosh. Plus 5. So y'all tell me, what is negative 3 times negative 1/3? Do y'all remember how to do that?
It's on 1.
Good, it's just going to be 1. Remember, the 3's will cancel because this negative 3 is like negative 3 over 1. So if you have 1 in the top and 1 in the bottom, they cancel. And then a negative 1 times a negative 1 makes a positive 1 plus 5. So x is going to be 6. So what this means is these two lines, if you got them both in y equals and you graphed them both, they would cross at the point 6, negative 1/3. So that's how you do substitution. Would y'all like for me to show you how to do this one with elimination? Because I actually think elimination might be easier on this one. Before y'all go, like, actually take your notes, would you like to see me kind of do one and walk you through it?
Yeah.
Okay. Is that okay with everybody?
Yes.
Okay. Let's do, if it's cool with y'all, let's do the same one because we know this should be the right answer. So I'm going to go to a new page and just write the same thing. And then unless y'all have questions about the homework for me, y'all are good to go do your notes and assignment for today. Like I said, the notes video will be short. All right, so let's do the same one. So 3x plus 6y equals 16. And x plus 3y equals 5. Okay. With the elimination method, instead of solving one of them and then plugging into the other one, here's what you do with elimination. So if it looks kind of weird, don't worry. It's brand new. You're going to take notes on it. There's a video of me teaching it. But what you do with elimination, you line them up, and then you're going to try to eliminate one of the letters. So let me show you what I'm talking about. Actually, I don't know why I rewrote that. Let's just use it right up here. I'm gonna write this other one in blue underneath it. So I'm gonna line it up. Make sure your X's and Y's are all lined up. And then I wanna see if I can get either the X's or the Y's to cancel out. Because it's called elimination. We wanna eliminate something. So if I can get either the X's to go away or the Y's to go away, then I should be able to find whatever's left. So which one do you guys want me to cancel?
The X.
Okay, we can cancel the X's. So let me ask y'all a question. Does everybody see how this says 3X right here?
Mm-hmm.
What would need to be with this X for these to cancel?
A -3.
Good, Shania. So what we need to do is multiply everything down here by -3 and it'll cancel out. So if I multiply by -3 on the first one, just make sure you do it to every other term. I need to multiply this one by -3. So instead of +3, if I do +3 times -3, what will this be now?
-9y.
-9y, good. Just remember, whatever you do to one term, you got to do to all of them, -9y. And then if I multiply this by -3, what's 5 times -3?
-15.
Good. So does everybody see now how these 3's will cancel?
Yeah.
They're just gone. So now look at what you have. 6y minus 9y. Do y'all agree that's -3y?
Mm-hmm.
Okay, and then 16 minus 15 is
1.
1. So how would you get y by itself?
Divide by -3 on both sides.
Good. Divide by -3. Divide by -3. So y would be -1/3, which is good because that's what we got last time, right?
Mm-hmm.
So it doesn't matter which way you do it, you're going to get the same thing. But I hope you guys will see this one ends up being a little more or a little less steps. So now with elimination, from here on out, it's the same steps as substitution. So I'm going to take this y equals -1/3, and I'm going to go put it into this equation for that y. So this is going to be x plus 3 times -1/3 equals 5. And now we just simplify. So again, 3 times -1/3, that would be -1, right?
Yes.
The 3 cancel. So this is just x minus 1 equals 5. And how would you guys get the x by itself?
Add 1 on both sides.
Add 1 to both sides. So what would x still be?
6.
So does it matter which method you use? But I want y'all to look. A lot of times elimination is less steps. Look at the work here and look at that one. It's a little less work. So if you can make sense of it and you can say, okay, to make those cancel, I got to multiply everything by this and do it. It does end up being a little bit quicker sometimes. Okay? He joined late. Do y'all have any questions for me?
No.
If you needed help on any of the ones from the homework or the classwork yesterday, stay on. I can help you with those separately. My other people, as long as you're good with substitution, I kind of just walked you through what we're doing today. So go watch those short notes videos, take notes, and then you're good to do your assignment. All right, y'all.